Very good morning, students. For this lecturing video session, I am going to start the unit 1, which is statics of particles. Statics of particles. So before getting into the this chapter, that is this first unit, statics of particles, let me just give some introduction about the engineering mechanics. Right, engineering mechanics. Right. Mechanics. What do you mean by engineering mechanics? Engineering mechanics is a branch of science which deals with the behavior of the body with a state of rest or motion subjected with the action of forces. Right. So it's basically the static means rest, that is rest or motion. They talk about the engineering mechanics. So engineering mechanics is further classified into two. It's classified into two. It is mechanics of solids and mechanics of fluid or fluid mechanics. Mechanics of fluid or fluid mechanics. So mechanics solid, the mechanics which dealing with the behavior of solid is known as mechanics of solids. Right. When you talk about mechanics of fluid, the forces, and this is a study of forces and motion on fluid is termed as mechanics of fluid. The fluid can be liquid or the gaseous form. Right. So mechanics, fluid mechanics further classified into ideal fluid, viscous fluid, and incompressible fluid. So then it's a broad idea about these branches of mechanics of fluid or fluid mechanics. Then the thermodynamics, heat transfer, refrigeration, air conditioning, which follows under the mechanics of fluid with and without heat. So let me just give this clarification. That's the classification on mechanics of solid. This is further classified into two. That is mechanics of rigid bodies, mechanics of rigid body, and mechanics of deformable body. Mechanics of deformable body. Right. So rigid body is in the sense it doesn't deform under the action of forces, whereas deformable body is the body which deforms under the action of forces. This mechanics of deformable body further classified into three. That is strength of material, theory of elasticity. The third one, theory of plasticity. Right. So as far as mechanics of rigid body is concerned, it is further classified into two. That is statics and dynamics. Statics and dynamics. What do you mean by static? Static is defined, right, it's a branch of science. It is defined as a branch of science which deals with the behavior of the body when it is in rest condition. Right, that talks about the statics. Example is the multi-story building, bridges are of static object. See, dynamics. So dynamics again is a branch of science which deals with the behavior of the body when it is in motion, right? So for an example, the moving car is the example of dynamics, right? So this dynamics is further classified into kinematics and kinetics. What do you mean by kinetics? Kinetics is a study of a body when the body is in motion without considering the force that causes the motion, right? For an example, if a ball, that's a football which is rolling on the ground, is an example of kinematics. So kinetics, what do you mean by kinetics? Kinetics is study of a body when it is motion with considering the force that causes the motion. Kinetics is, suppose a football is ideal position, that is it's in a resting position, static position, and if a boy kicks the ball, that is the force is applied on the ball, right? That talks about the kinetics. So as far as our syllabus is concerned, for the engineering mechanics of G8292 is concerned, we are going to going to learn under this category only. So mechanics of rigid body only, that is statics, dynamics, kinetics and kinematics only. So for the higher semester, probably you will study the strength of material, theory of elasticity, theory of plasticities and mechanics of fluid or fluid mechanics. So as far as our syllabus is concerned, we play with only these three parameters, that is statics, dynamics, kinematics and kinetics. That's four categories, right? So next I am going to give a brief idea about the basic concepts or the basic fundamentals of statics, right? Basic concepts or basic fundamentals. Basic concepts. That is rigid body, particle, then deformable body, then mass, weight, then force, scalar quantity, then vector quantity, then unit and dimension, unit and dimensions and momentum. So broadly I am going to give a brief introduction and the definition of the 10 basic concepts of the mechanics, right? First, rigid body. What do you mean by rigid body? A rigid body is a body having mass and dimension. The body which doesn't deform under the action is called rigid body. For an example, a road roller which rolls on the road, which is talk about the rigid body, right? Then particle. What do you mean by particle? A particle is defined as a body whose space and dimensions are considered as negligible. The mass is assumed to be concentrated on a point or a specified point. For an example, a ball is kept on the table is the example, the ideal example for the particle, right? So let me just move to the third one, which is deformable body. What do you mean by deformable body? It's a body which deforms under the action of force or the external force, that is deformable body. Suppose if you have a sheet metal box and if I hammer it by using a sledgehammer or whatever the hammer, that box, that is a sheet metal box, deforms. So that is nothing but the deformal body. Then mass. So mass is so let me just give the differentiation between the mass and weight. See, you would be having the confusion what is mass and weight. So I am going to give the distinguish, that is the difference between mass and the weight. So mass is a quantity of matter contained in the body. It is the quantity of matter which is contained in a body is mass. What do you mean by weight? It is a force. It is a force with which the body is attracted, which is attracted towards the center of the earth. Right. So mass is a scalar quantity. It's a scalar quantity because it has only magnitude, whereas the weight is a vector quantity. It's a vector quantity. That means it has both magnitude as well as direction. So as far as mass is concerned, it is never zero. It is never zero at any location. Right. So as far as weight is concerned, it is zero at the center of the earth. It is zero at the center of the earth. Right. And the fourth one, it resists the motion. Resists the motion. It resists the motion. It provides the motion. It provides the motion. And the unit of mass is specified in kg. Whereas weight is concerned, it is specified in Newton. Right, the unit of mass is kg, this is Newton. So the formula for weight is m into g. M is nothing but the mass of the body, g is nothing but the acceleration due to gravity. Acceleration due to gravity, which is equal to 9.81 meter per second square. Suppose astronaut's weight is 100 kg, for an example 100 kg, right? So his mass would be constant at all the places, whether it is in the earth or he is in the space. Suppose he is in the earth, his mass would be 100 kg, right? And whose weight would be m into g, that is 100 into 9.81, which would be 98.1, right, kg. Right, kg. When these astronauts in the space, therefore there won't be any gravity. See, as far as when he is in the earth, due to the gravitational pull, his weight would be this much. When he is in the space, the weight would be zero. The reason behind, mass would be there, but there won't be any gravity, so his weight would be zero. That's the reason the astronauts would be flying in the space. Right. Hope you have understood clearly the difference between mass and weight. Right. So next is force. What do you mean by force? Force may be defined as a motion in the form of push or pull, right? Push or pull extracted by one body on another body. Force tends to move in the direction of the action. For an example, so let me just give some of the characteristics of forces. Characteristics of force. Characteristics of forces. The first one should be magnitude. There are three characteristics of forces. First one is magnitude, then direction and the point of application. Point of application. So let me just take the object as a duster, right? So now I am going to give a small demonstration. So the characteristics of force. So let me assume the magnitude of force as 10 kilonewton, and the direction would be in the positive x-axis. This is a positive x-axis direction. The point of application would be here. So this is the object. Now I am going to apply some force that is 10 kilonewton. Look at here, the 10 kilonewton on which direction? X-axis, that is positive x-axis direction I am going to give. And what about the point of application? The point of application I am going to give here. So when I just give so much of Newton on positive x-axis and the point of application here, the body tends to move. So this is the force and the three characteristics of the forces, right? And next one is scalar quantity. So scalar quantity, what do you mean by scalar quantity? It's a physical property which has only magnitude. It has only magnitude. Scalar quantity which has only magnitude. It is independent of direction. Has only magnitude. Right. So then the variables which has only magnitude are, the examples are mass, then temperature, then length, then height, work, power or pressure, and the list goes on. Which has only magnitude, magnitude in the sense, so mass, 10 kg of mass, which has only magnitude. If it is of temperature, so much of degree Celsius or so much of degree Fahrenheit. So 96 degree Fahrenheit, so much of temperature. So which has only magnitude. When you talk about length, so 3 meter length, or height, so 2 meter height, whatever. Similarly, for work, pressure and power, which has only magnitude. So scalar is a physical quantity which has only magnitude. It is independent of the direction, right? Then what about vector? So vector quantity, let me just give say explanation for vector quantity. So vector quantity. Vector quantity is a physical property, it's a physical quantity which has both magnitude and direction, which has both magnitude and direction, right? See, example for the vector quantities are which has both magnitude and direction, right? So in this scenario, velocity can be written, momentum, acceleration, then force. So and the list goes on, right? Which has both magnitude and direction. Let me just give example for velocity. What do you mean by velocity, by the way? It's traveling, that's a distance travel by time. So as far as the magnitude is concerned, so much of speed it is traveling, right? Direction in the sense, which direction it is traveling. So the unit of this is meter per second, that is distance traveled by time taken. It is traveling at what speed? and in which direction it is traveling. So which has both magnitude and direction. So it is a vector quantity, right? And the unit and dimensions. What do you mean by unit? A unit is defined as a numerical standard used to express the qualitative measure of a physical quantity. So the fundamental units are the fundamental or the basic units. Basic units are length, mass and time. This is the fundamental units. Then derived units, there are even derived units are there. There are a lot of derived units there. Derived units, which are the volume, velocity, density, acceleration, force, and the list goes on. So the basic units are length, mass and time. So the derived from there, it is all other variables are derived. The physical quantities are derived, right? So now I am going to give the explanation on system of units. System of units. There are 4 types of system of units followed. The first one is SI, that is International Standard. SI, system of units. SI, system of units. System of units. The second one is MKS, system of units. And the third one is CGS, system of units. And the fourth one is FPS, system of units. So what is SI? SI is nothing but the international system. International system. And MKS, which is nothing but meter, kilogram and second. And second. Meter, kilogram and second. CGS, that is centimeter. Centimeter, G is gram and S is second. And what about FPS? F is foot and P is pound. S is second. So these are the 4 types of system of units. See, as far as engineering mechanics is concerned, we follow SI system, that is international system. So the most of the countries, they adapt to use SI systems, right? So next, dimension. What do you mean by dimension? Dimension. It is a dimension is a qualitative description of physical variables is known as dimension. The qualitative description of physical variable is known as dimension. So here also, as far as unit is concerned, I taught you there are 2 types. That is basic unit and the derived units. See, as far as dimension is concerned, there are 2. That is primary or basic. Primary or basic dimension and secondary dimension. Secondary dimension. The basic dimensions are length, mass and time. And the secondary variables are derived from it. That is volume, area, velocity. Those are secondary variables. So let me just give some idea about unit and dimension. How to mention the unit and the dimension. So let me just put a table form so that it will be you would be in a position to understand in a better manner. So let me just give the quantity here and the unit here. Next, the representation. How to representation of unit and the dimension in terms of MLT format. MLT is nothing but mass, length and time. Right. So let me just give some example for it. See the basic, I told you that basic units. What are the basic units? Length, mass and time. These are the basic units or basic dimension. So now listen carefully how I am going to mention the unit here. Right. So the unit of length is meter. How this can be represented in terms of unit? It is small m. Right. So the length, it is MLT format. So the dimension of this length in terms of MLT is L. When you talk about mass in this is kilogram. Right. The unit is kilogram, which is specified in kilogram. So the representation of unit for mass is kg. What about the dimension? Here it is mass, therefore it should be mentioned as m. Right. Next, time. Time is in second. The unit of time is second, and the representation of unit is small s. What about dimension in terms of MLT format, which is t? So these are the three basic units or the primary dimension. Now the derived, these are basic unit or basic dimension. Now I am going to the derived one, that is derived unit or the secondary dimensions. Look at here. Now I am going to mention the area. So let me just wipe off this one so that I can write something to make you understand. So area is, what is the formula of area? That is length into length, isn't it? That means meter into meter, because the unit of length is meter. So which is meter square. This is as far as unit is concerned. What about dimension? Length and length. What is the length here? It is L. So L into L, that can be written as L square. Clear? So as far as unit is concerned, what is the representation of unit? Here it is m. So m into m square. So here it is meter square or square meter. How this can be written? Meter square. And how this can be written? L square. Got it? So next, volume. Let me just give the example for volume. Volume is length into length. That is, in terms of unit is concerned, this m into m. Look at here. What I mentioned, length. It is m. So m into m, which is m cube. This as far as unit is concerned. What about dimension? What is the representation here? It is L. So L, that is equal to L cube. So for volume, it could be cubic meter, and this can be written as m cube, and this can be written as L cube. Right. So next I am going to give the example for velocity. What is the definition for velocity? It is the distance traveled by time taken. That is, distance traveled by time taken. Distance travel is nothing but so much distance, that is length or meter, right? That is in terms of L, some distance divided by time taken. Time taken. So time taken is in terms of second, that is t. So this can be written as L into t power minus 1, right? Velocity. Velocity, see here it is meter per second. The reason why it is distance travel. So in terms of unit is meter and the time taken, which is nothing but the second, that is meter per second. So here it can be written as meter per second. How this dimension can be written as? In terms of MLT format, you will have to use it. So LT the power minus 1. So this is as far as velocity is concerned. When you talk about acceleration, that is velocity by time. Velocity by time. What is the unit of this one? Here it is velocity, that is meter per second and divided by second. So which can be meter per second square, right? Meter per second square for acceleration. Acceleration can be written as meter per second square. So meter per square seconds. In terms of dimension, we'll have to use MLT format, right? MLT format we'll have to use it. So velocity, you know, it is already been arrived as LT power minus 1 divided by time is t, that is time is t, therefore this can be written as L t power minus 2, L t power minus 2, L t power minus 2. I am going to give one more example for this, that is force. What is the definition? Mass into acceleration, that is MA, that is mass into acceleration. So mass, how this can be written as? Mass is in terms of kg. So force can be written as mass into acceleration. So mass is kg, and what about the acceleration? Meter per second square. So here you can use mass per, what is for acceleration? Meter per second square. So here also you can mention kilogram per meter per square seconds. Then in terms of dimension, so we will have to use MLT format. So mass is m, so you can mention as m. What about acceleration? Look at here, acceleration we have already arrived in terms of MLT format, that is LT power minus 2. So here you can use it as MLT minus 2. So similarly for density, work, pressure, we can just return in terms of unit as well as in terms of MLT format, right? So here I have taught you the unit and dimension. This comes under the basic concepts. These are the basic concepts, right, of mechanics. So now momentum. What do you mean by momentum, by the way? So momentum is defined as the measure of the motion of the moving body, which is nothing but momentum can be written as is a product of mass and velocity. So product of mass and velocity. Let me just give an example for it. So an automotive vehicle. An automatic vehicle, assume it's a road. Assume a road. A car and a bus. A bus which is moving in a constant velocity. That means in the same velocity the car and bus are traveling in the positive x axis, right? So now suppose the both drivers of car and bus want to apply the brake at the same time. At the same time they need to apply the brake. Which one stop first? The car will stop first. The reason behind, the mass is less than of bus. The car mass is less than the mass of bus. So the car will stop first and the bus, because they need to apply more force on the pedal to stop the bus. So where you have more mass and the momentum will is proportional. So this is the example for this one, right? So I have taught you all the basic concepts of the engineering mechanics. So in the upcoming videos I will give the laws of mechanics in a detailed manner. Hope you have understood the basic concept of engineering mechanics. Thank you.